Okay, so here, a little bit of a thought question about without graphing, determine whether these two quadratic functions shown below will intersect one another. I think the easiest thing here is to just think about a quick sketch. Well, let's think about what's going on with this one. So first, this one, we can see that a equals 1, so there's no vertical stretch or shrink from the parent function. And we can see that h equals 0 and k equals 1. So this is going to be just a parabola that moves up 1 unit. This one, we can see that a equals 1/2, so it's going to be a shrink, vertical shrink, I should clarify. H also equals 0 for this one, but k equals -1, so it's going to go down 1. Alright, let's see if we can just reason through with a graph here whether these things will intersect each other after we transform them. This is the parent function, f of x. Well, I'm not even going to call it f of x, I'm just going to call it the parent function. So first one is, I'm going to do g of x first because that's easy. All I'm doing is taking this one and moving it up 1. It's going to have the same shape. So this one right here is g of x. F of x, we know, is going to take the parent function and it's going to move down. And it's going to be a vertical shrink, so it's going to actually get flatter. Its arms are going to move out. So I'm not sure I care exactly how flat. I'm going to go ahead and draw it this way. And then I'm going to go ahead and maybe just erase that parent function that I started with. Well, you can see that g of x and f of x are really never going to intersect, because when we transformed them, they moved apart. And so that already, they moved apart, and then one of them got, this bottom one got flatter. So by getting flatter, it ensures that it'll never intersect this one, which stayed at the same shape. So this is kind of what I had in mind with this question, is through reasoning this way, they will not intersect one another. Because, again, they moved apart, and the bottom one got flatter. Okay, last question here. Two lengths of two sides of a rectangle. That shouldn't be a little typo. That should say the length of two sides of a rectangle add up to 4. What is the largest area of rectangle that you could form? Well, first we need to just remember back from geometry that if I have a rectangle and one side is A and one side is B, the area of that rectangle is the product of the sides. So here we're given that the lengths of two sides of a rectangle add up to 4. So if I call this one x, this side will clearly be 4 minus x, because that way when I have x plus 4 minus x, add those together, I get 4. So now my hint here says write an expression for the area. Well, we know the area is both sides, or sorry, the product of the two sides. So one side is x, one side is 4 minus x. If I go ahead and, well, I'm going to go ahead and multiply that out. 4x minus x squared. I'm going to write this in our normal order here, minus x squared plus 4x. Now if I want to factor this, I can put this into intercept form. The idea here is I'm trying to find the largest area. Well, if I graph this parabola and I can find what its highest value is, that'll tell me where the highest area is occurring. So I need to figure out how to graph this guy here. Well, this is pretty easy to put into intercept form. If I factor out a -1, I'm left with x squared. Sorry, if I factor out a negative x, I'm left with x minus 4. And with a little clever rewriting, I can write that as -1 just to see what's going on here. So I'm rewriting this x as x minus 0 and then x minus 4. So we can see that this looks like a nice intercept form problem. So if I go ahead and just do a quick graph here on the x-axis, this axis is the area axis, or y. So our intercepts will be here at 0, 0 and at 4. And if we recall, we know that a is negative 1 here, so this is going to be a frown parabola. And so the axis of symmetry is going to be halfway in between, where x equals 2. And we know that that's going to go through the vertex. So wherever this occurs, the maximum is going to occur at x equals 2. So that's all I need to do here is find the area when x equals 2. If x equals 2, one side is 2, the other side is 4 minus 2, which is also 2. So 2 times 2 equals 4. So if I have the biggest area I can come up with is an area of 4 when each side equals 2. So actually it's when that rectangle is a square. But again, the idea here was to think about this problem as finding the vertex, because the vertex will give us maximum and minimum values. So our clue for that should have said, when I find what's the largest area of the rectangle, my brain should say, ooh, I'm going to need to graph something and find where that vertex occurs. Just like if I would have said find the smallest area of something or smallest something of something, it's probably going to be a problem like this where you're trying to find where the minimum value of the parabola is.